Greetings, students. Let's discuss practice test 10. Let's begin. Question 1. Identify all holes, vertical asymptotes, and horizontal asymptotes. So, for holes and vertical asymptotes, we're looking for when the denominator is equal to 0. So I set x minus 1 equal to 0. I get x equals positive 1. Now, is this a hole or an asymptote? It's a hole if I can cancel it out with the numerator. It's an asymptote if I can't. So that is an asymptote. So asymptote at x equals 1. Not a hole, but an asymptote. Horizontal asymptotes. You're looking for if the denominator is higher degree than the numerator, or if they're equal degrees. Well, in this case, the denominator is higher degree. So that means I got a horizontal asymptote at y equals 0. Two asymptotes here. Alright, next question, same questions. Now on these, notice this one has the denominator bigger than the top, so there's no horizontal asymptote here. So we're looking for holes and vertical asymptotes. So I'm going to factor the numerator because it's a quadratic. Always factor if it's a quadratic, or if it can be factored. So that numerator factors into x minus 4 times by x plus 2. The denominator, you can pull a negative 4 out from that. Negative 4 times by x minus 3. So I'm looking at these numbers. If these had canceled, if there's been x minus 4, then I wouldn't have an asymptote, I'd have a hole. But because it's x minus 3, and these are different, all three of them are different, that is in fact an asymptote. So once again, we have an asymptote we said x minus 3 equal to 0. X equals 3. Alright, here again we're going to factor the denominator. We're going to have 3x negative over x minus 3 and x plus 1. Alright, again those are all different factors. So that means we do have asymptotes at both of those values. So I said x minus 3 equal to 0. I get x equals 3. I said x plus 1 equal to 0. I get x equals negative 1. And then also the denominator has a higher degree than the numerator. So that means my horizontal asymptote exists at y equals 0. So this has 3. Asymptotes at x equals 3, x equals negative 1, and y equals 0. 3 asymptotes. Remember, if one of these had canceled, it'd be a hole instead of an asymptote, like we talked about during the lessons. State the excluded values. The excluded values are when the denominator equals 0. When the bottom is 0. So all I have to do is set 10b minus 80 equal to 0. Add the 80 over. Divide by 10. B cannot equal 8. B can't equal 8 here. That is also a hole on this function. I shouldn't say function, it's not continuous. On this expression. It's also a hole here if it was f of x equals. And yeah, b can't be 8. Same thing here. I'm going to do the same thing. Set 40p squared minus 40p equal to 0. Solve for when this is equal to 0. So factor a 40 and a p out. 40p times p minus 1 equals 0. So p cannot equal 0 and 1. P cannot equal 0 and p cannot equal 1. The 0, p equals 0, would be reducible out, so that is a hole instead of an asymptote. Oh, and I forgot to simplify these as well. It says to simplify. So p can't equal 8, p can't equal 1. Also simplify here. So b minus 8 over 10 times b minus 8. The b minus 8's cancel. You get 1/10. And then here, the p's would cancel like we talked about before. And then this 24 and the 40 would reduce as well. They would both divide by 4. Oh, by 8, actually. And it would be 3 in the top. And then 5 times p minus 1 on the bottom. I did say to simplify, so I should have done that too. Anyways, so I got those by, again, dividing this by 8, then this by 8, and the p's canceled, and here the b minus 8's canceled. Alright, here, fact to the bottom, 8r squared times by r plus 4. Notice that r plus 4 cancels with the r plus 4 there. So this and this are gone, this and this are gone. So my reduction here, there's only a 1 left in the top, and there's 8r squared in the bottom. There's my reduction. Excluded values, 6, negative 4, and 0. So r can't be 6, because you can't have the bottom equal to 6 here. R can't be negative 4, and r cannot be 0. The 6 and the negative 4 would be wholes, the 0 would be an asymptote. If I were to ask you to graph it, I didn't ask you to graph it though on these. Alright, here, when you divide, you flip it upside down. So I'm going to rewrite this with the bottom factored here. That factors into a minus 7 and a minus 3. That minus 7 will cancel. This x minus 3 does not cancel. So I simplified expression, 3x over x minus 3. X cannot equal 7, and x cannot equal 3. X cannot be either of those two values. Cannot have the bottoms equal to 0. Again, excluded values when the bottom is 0. Next page. This just says simplify. So these we don't have to find the wholes or asymptotes to simplify. What we're going to do here is cross multiply. Shouldn't say cross multiply, there's no equal sign. We're just going to take the bottoms times the tops. So here we distribute 5n plus 40. 5n plus 40. This is a negative 4, so it's not a positive, it's minus 4. So it's minus 20n minus 24. Simplify that out by combining like terms. 5 minus 20 is negative 15, and 40 minus 24 is 16, plus 16. The denominator here will be a combination of these two multiplied together. You do not have to multiply it out. Just write it as factors. 5n plus 6 times by n plus 8. 5n plus 6 times by n plus 8. Both of these work the same way. There was supposed to be one that was times and one that was, or excuse me, one that was plus and one that was minus here. I made them both minus here on the review because minus is the harder thing to do. So keep in mind on the test, one will be plus, one will be minus. Anyhow, multiply here. 2n times n, 2n squared. 2n times minus 5, minus 10n. Again, that's negative 7. So it's going to be negative 7 times 4n squared. So that's minus 28n squared, not plus, minus. And then here, 7 times 28. You can use the calculator, of course, on the test. I would recommend that. 7 times 28 to get that value out correctly, 196. Combine like terms. 2n minus 28 is negative 26n squared. Negative 10n minus 196 is negative 206n. And again, the denominator here will be a combination of these two multiplied together. Now, sometimes this might reduce out. So here I'm looking at this and I'm seeing this n. This n is going to reduce out. So this does have an extra step of reduction. So this would be 2n times by 4n squared plus 28n. I'm looking at this 2. It's going to divide into both of these. I'm looking at this n. It's going to divide into both of these. And I'm thinking about this 4. This 4 might also divide into both of these. So I'm looking at 206 divided by 2 first. 206 divided by 2. That's 103. Does that divide by 4 or by 2 again? No. So we're good. We just have to divide by 2 and by n. So we are going to reduce this n out from both of these and then divide both of them in half in the top before I finish my answer. The negative can come into the front or it can stay in the top in the numerator. So it's fine where it's at, or it can come into the front. So negative 13n minus 103 divided by 4n squared plus 28n. There we go. Alright, solve each equation. You're going to multiply by the denominators here. Multiply by the least common denominator. So you can start off by multiplying by whatever you want to multiply by. So multiply by the k if you want. It's going to cancel out one of the k's here and one of the k's here. So you can do this slowly if you want to. Let's say I multiply everything by 5 first. That's going to cancel out the 5 here, the 5 here. This doesn't have a 5, so that becomes a 10. So if I times this by 5, it's going to become this. Because that last one didn't have a 5, the top became a 10. So now I can do this slowly if I want to. I don't have to do this all together. Now I can multiply by the k. That's going to cancel out this k and one of these k's and one of those k's. Well, let's just multiply by k squared. So I cancel out both those k's, both those k's. This only has one k. So I'm going to have to put a k in the top here now. So all the denominators are now gone. There's a k in the top there, a 4 in the top there, and a 10 in the top there. 4 from 10 is 6. K is 6. You can check your work very easily here by putting the 6 back in on a calculator. So because I'm going to use a calculator, you might want to do the work in the calculator here to check your answer. 1 divided by 5 times 6 plus 4 divided by 4 times 6 squared. That is 0.061. I can make that a fraction if I'd like. I just have to check to see if it's the same as 2 divided by 6 squared. Oh, sorry. You see my mistake? Right there I used 4 times 6 squared. Should have used 5. So if I go back, if I want to go back, I could do second entry to go back and retype in. Instead of a 4 there, I wanted a 5 there. It's a good idea to check your work like I just did there on the calculator. And again, you can do second entry if you want to go back and change something from what you typed in if you made a mistake like I did. Didn't do it on purpose. But if you do make a mistake like I did, you can retype it like that. Alright, same deal here. Factor the bottom on this first one, this first expression. So that's x times x plus 7 plus 1 over x plus 7 equals x minus 1 over x. So look at this. We're missing an x in the bottom of this one. We're missing an x plus 7 in the bottom of this one. So what I get, I'm going to times by. I'm going to times by the x, which is going to cancel out this x and put an x here. So there's an x here. I'm also going to times by x plus 7, which is going to cancel out this x plus 7 and this x plus 7. So that means that's just going to be a 7 plus x. But this is going to have to distribute because this doesn't have the x plus 7 here. It's going to have to distribute. So x times x is x squared. X times 7 is 7x. 1 times x is minus x, and then minus 7. Now I have a quadratic I need to solve. I'm going to have to solve this quadratic. 7x minus x is 6x, minus another x is 5x. 7 minus from 7 is 14 negative. So this is x squared minus 14x. Excuse me, not 14. We said 5x already. X squared minus 5x minus 14. It would be nice if this factored. It looks like it does. 7 and 2 makes 5. So those are going to be my answers. X is equal to positive 7 or x equals 2. It's x minus 7 and x minus 2. I can go back up here and make sure that I can put 7 and 2 in, and it looks like I can because the excluded values are negative 7 and negative 2, not positive 7 and positive 2. And again, if I want to, I can type this in the calculator and verify that one of those answers works. You don't really have to verify both, because if one of them works, you did it right. So let's check the 2. 7 divided by the quantity 2 squared plus 7 times 2 plus 1 divided by the quantity 2 plus 7. So I put 2 in for x there. Put 2 in for x. We get 1/2. And then we do 2, quantity 2 minus 1 divided in half. That's a half. Yeah, 2 works. That means I did this question right. Because if 2 works, the 7 works, because that's where I got the factors from. Alright, a boat travels 210 miles downstream, and the same time it takes to travel 150 miles upstream. So distance equals rate times time. The rate here is equivalent. The rates are equivalent. Rates are equal on this problem. The boat does not travel at a different rate in still water. It has a maximum speed in still water. The rates are equal. So what we're doing here is R equals D over T, actually. We're going to solve this for R, distance over time, since the rates are equal. Anyhow, so I can take 210 divided by, when I'm going downstream, the water pushes me faster, x plus 4. When I'm going upstream, the water slows me down, x minus 4. You could say that instead of x, that could be R, the rate plus 4 and the rate minus 4. Because that's 4 miles an hour is going to speed me up by 4 miles an hour going downstream, and it's going to slow me down going upstream by 4 miles an hour. Cross multiply here, I shouldn't say cross multiply, I should say just multiply. 210 x minus 840, 210 times 4, is equal to 150x plus 600. 150 from 210 is 60x. 840 plus 600 is 1440. And the last step here, 1440 divided by 60, will give me the rate of 24 miles an hour. Its base speed. Finished. Alright, solve using a graphing calculator. You can use a graphing calculator here, you can do these by hand. This is the same as the questions above, 11 and 10. So if you want to use a graphing calculator here, what you're going to do is you're going to plot all 3 of these and figure out where they cross, what values of x they cross at. If you want to do it by hand the same way we did above. You do not have to use a calculator if you don't want to. In fact, it might be easier just to do it by hand. So what am I going to multiply by? I've got an x squared and x squared, so I'm going to have to multiply by x squared. And this one's missing it. It's only got an x, so that's going to change that into an x in the bottom there. What else do I have? I have a 4 here and a 2 here. So I'm going to have to use a 4 here. This one doesn't have a 4, so that's going to be 12 plus 60, 12x plus 60. I have to multiply that one by 4, in other words. This one has a 2, not a 4. So I'm not going to multiply it by 4. I'm going to multiply it by 4 divided by 2, which is 2. So that's going to multiply this by 2. It's going to become 2x minus a 6. There we go. So I got 12x plus 60 equals 3x minus 6. 3 from 12 is 9. 60 and negative 6, negative 66. I'm just checking my work here, thinking about if I did something wrong. Doesn't look like I did. 6 divided by 9 is 7 2/3, or 7 1/3. I'm not spotting if I did something wrong there. And if it comes up as a decimal, it comes up as a decimal there. It might come up as a decimal. And again, your other option here is to plot these, which you could also use on these up above. So I could do the quantity, 3x plus 15 divided by the quantity x squared as my first graph. Second graph, 1 divided by quantity 4x. Third graph, x minus 3 divided by the quantity 2x squared. And hopefully we're going to see they cross at 7 2/3. They share the value at 7 2/3. And it's kind of hard to see actually where they're at. -7 plus 2/3. minus 1/3. Sorry, not 2/3, 1/3. So yeah, that's how you would use a calculator to solve this. You check it like that, and then you check to see if they have all the same value there, the same y value. Looks like they're different to me. I'll come back to this one on the comments below if it doesn't work out, or if I did something wrong, then I'll come back to it and I'll fix it. Anyway, simplified complex fraction, keep, change, flip. You're going to multiply by 4/1 here to get rid of the 1 and the 4 on the bottom. All right, so that's going to change that into a 4x over 5 minus 100 over x squared. We do want to combine the denominators together, so multiply here across again. So you have one denominator. You don't want multiple denominators. 4x to the third minus 500 divided by 5x squared. There you go. Alright, so on this one, combine the denominator together first. So we have the 8 over x in the top here. Here we're going to have 8, 2 times 4, plus x cubed over 4 times x. Come on in. And then times by 4x over x cubed plus 8 in the bottom. Cancel out the x's here. And then you'll have your finished answer. 32 over x cubed plus 8. There we go. I'll look at this one when I go up to my desk and put the video in. If it's not 7 1/3, I'll explain it in the comments. Good luck.